Hey, welcome back to Fix It Friday. So this week we're going to be going back to the good old NES, and we're going to be talking about the Nes Rgb mod. This is a mod that's been around for quite some time. It was developed by Tim Worthington, and it allows you to get the highest quality analog video from your NES. And then from there you can take that RGB video and connect it to devices like the open source scan converter and get really amazing video and audio on a flat panel display. So, I've gone over this actually before in the channel, but today I'm going to be doing something a little bit new. So normally when you install this, you've got to cut a whole bunch of holes on the back of the console. You need one for a palette switch, you need one for the RGB connector, and ideally I prefer not to make any kind of modifications to shells whenever possible. Sometimes it's unavoidable, but it's better if you can just leave this alone and make something that's reversible and doesn't do anything destructive. And so thankfully, some people have done precisely that. This is a new board that's been developed. It's called the NES IO, and it was done by Borty4938 and a couple of other awesome people. And what it does is it pairs up with the NES RGB, and it does a couple of different functions. One is that it takes care of the power management for you. It's got a modern regulator. It's got a bridge rectifier, so you can use the original power supply or a DC power supply, no problem there. It's got a fuse, so you have your console protected. That's awesome too. It's got these PIC chips, which allow you to do in-game reset with a button combo and also change palettes, so you don't need a switch on the outside to do palette swaps. And the best thing is that it fits right over here, so that S-video, RGB, and composite video are all accessible from the existing ports, and you don't have to cut the shell at all. And in this particular case, I really didn't want to cut the shell because this is a really nice one. This is a very old NES. It's got a flat, smooth top instead of a textured top. And looking at the serial number, that makes it roughly produced around like maybe 1986 or 87. So what's great is you can do all this modification. It's fully reversible. You get all of the awesome benefits, and you don't have to mess around with the case. All right, so we're going to go through this step by step, and let's get to it. All right, so I'm not going to go into how to take apart an NES because that's definitely one of the easiest things possible. Really, all you need is a Phillips screwdriver, and you just got to take all the screws out that you can see. The only thing to bear in mind is that there are two screws that are a little bit longer than the rest, and they normally live right over here on these two sides of the cartridge connector. That's about it. Otherwise, it's pretty straightforward. As soon as you see a screw, you get rid of it. That's all there is to it. So now I'm going to go ahead and just remove the power connector here. And then there's also these controller ports that need to go. Okay, so basically what we're going to do today is we're going to start by desoldering a very large number of things. First thing is a standard practice for the NES RGB. We have to desolder the PPU and replace it with a socket, which is right here. I've done this before on the channel, but I'm going to go through it again. And basically what we're going to do is we're going to start with the desoldering gun. Well, first we'll add some fresh solder, then use the desoldering gun, and then follow up with the hot air gun to get rid of the last little pieces of solder that are keeping it stuck on, and we can pry this off safely. We'll replace it with the socket, and then the next thing that we're going to be doing is we're going to be getting rid of this entire power module. So this thing is going to go, and it's going to be replaced instead by the new NES IO board. And you can see the shapes are pretty much the same. All right, so let's get started. Okay, so that was a lot of soldering, but I've managed to do a decent amount of work at this point. So the power module and RF modulator is gone. I did all of the installation of the sockets on the NES RGB. I also added a second socket because I didn't really want to solder the PPU to the board. I wanted to make it so that I could take it out if I ever wanted to. So I had a second socket lying around. I installed that here as well. And so everything just kind of snaps into place, and that was no problem. So yeah, just a note on removing this power module. You need a lot of heat, so it took me quite a while to get all of that off. In the future, I would suggest using something like Chip Quick to kind of break all of these ground points, because that's the thing that was holding it in. Like, removing the solder on these pins was easy, but getting the solder off of these ground plane parts were really awful. Okay, so now that this is all done, what else do we have to do? Well, there's still quite a lot left to do. I mean, all the main components have been removed, but we still have stuff to finish up here. So the way that this works is that the power module is gonna sit right here, and then I had desoldered this from the original RF modulator. That's gonna go right here, and then this guy, we're gonna flip this over like so. Yep. And it's gonna lock in to this. And then in turn, this is going to go and lock into the power module. So that's generally the idea of what we need to do. Apart from that, though, there's quite a lot that we need to solder. So we need to do all of the regular NES RGB connections from here to here. We also need to connect over control pad buttons, or I'm sorry, the control pad over to this section here. And then we also have to wire in a new LED and a few other components as well. So I'm going to go through that step by step, and I'm going to make sure I add some text and explain what I'm doing, because I think that'll just be more expeditious. Okay, so now that everything is wired in, I'll just kind of explain what I've done here. So I have a bundle of about 8 or so wires here. These are going to go between the NES I/O board and the NES RGB. So this is going to have all of our video signals and our sync and our sound, all of that. This set of 3 wires right here, these are going to go to various points on the motherboard. And this is the pulse, latch, and data lines, and so this is what's used for the button combinations, either for palette swapping or for resetting the system. This really long wire that I've got here, this is the reset line, so this is going to go again to some spot on the motherboard. I've got a set of 3 wires sitting right here. These are for changing the palette, and so that's going to go onto the NES RGB board. And then finally, this wire over here, this is the 3.3 volt line, so this powers some of the board, which requires 3.3 volts. All right, so that's all set, so now I'm going to get started with connecting everything up. Okay, so now we're at a point where we can combine the NES I/O with the main motherboard, and so what you can see here is that I have put in a few screws just to hold everything together and make sure everything's aligned. I also made sure that the RGB and the S-video are looking good in these ports, and same thing for the power jack, and all that stuff is looking just fine right now. So I'm going to go ahead and reconnect these things to each other. Well, actually connect them to each other for the first time. Alright, so that's done. Okay, so the next thing that we're going to do is we're going to go ahead and make a bunch of connections between the I/O board and the motherboard, because it's easier to do that before we go ahead and add this thing into the mix. Okay, so the first wire that we're going to add is the reset line, which is labeled as out on the NES I/O board. And so what we're going to do is we're going to solder that over here to the 4th pin of the power connector. Okay, and that's one of them. Alright, so the next one we're going to connect is the data line. And so that's this green wire over here. So I have to keep flipping the board over to make sure I read this correctly. But yeah, this is data. So this is going to be part of all of the various palette swaps and in-game reset. You need to be able to input button commands. So that's what this is. And so we're going to be attaching that to this pin 2 right here. This is U7. This is the chip related to controller pad 1. And we just need to attach this guy right here to this pad, to this pin right here. I think I'm actually going to flip the board over so I can see better. There we go. I just thought it was on, but it really wasn't. Okay, so now we're going to route this so that it's very safely out of the way, because we don't want it getting anywhere near where the NES RGB board is going to go. We want to make sure it's just kind of tucked in and out of the way. Okay, so now we're going to go ahead and add the latch and the pulse wires. And those are represented here by these blue and purple wires respectively. And the latch, which is this blue wire here, this is going to go all the way over here to pin 39. And then this purple wire here, that's going to go to pin 36 on the CPU. Okay, so that's all finished. And what I did was I actually routed both of the wires between the legs of the ceramic capacitor, and I did that just mainly so that I could control where the wires go. So I wanted them to form a nice straight line going from the I/O board to the CPU, and I just didn't want them to flop around or get in the way of anything. And using this is just kind of a natural way to hold them down. So I've got that all taken care of. And so those are all of the specific connections, I'm pretty sure at least, from the NES I/O board to the motherboard. So the next thing that we got to do is we have to add the NES RGB, and there are a couple of different connections that we need to make, most of them related to sound, that also go between the CPU and the expansion audio and go to the NES RGB board. Alright, so the next thing that we're going to do is take care of the audio on this board. And to do that, we're going to take audio that is generated from the CPU on pins 1 and 2, and we're going to put that onto pads A and B of the NES RGB board. However, we're also going to do another modification as well. So we're going to add Japanese expansion audio functionality to this American system. So to kind of briefly summarize, the American consoles don't have this feature of expansion audio. In Japan, there are a bunch of games, including Famicom Disk System games and some cartridges, that have this expansion audio connected, and so you can add extra channels of sound, and so certain games like Castlemania 3, for example, sound really different and frankly much better in the Japanese versions. So the owner of this NES wants that because they have a bunch of imports, and so they can play those, and then you can also use a flash cartridge like the EverDrive N8 Pro, and you can get that expansion audio as well on an American system. So to do that, first let's just get the regular audio in. So we're going to solder onto pin 1. Okay, so that's your standard NES audio all added. So now we're going to go ahead and do the expansion audio. Okay, so I've got the board flipped over, and this is where the expansion port is on the NES. This is a port that was never used in the United States, but in Japan this was used for a variety of different peripherals. So in order to enable expansion audio, you need to do two things. One is you need to take a 1 kilo ohm resistor and you need to link it up between pins 2 and 9 on the expansion port, and so that's what I've done here. The second thing I need to do is I need to take a wire, and from pin 9 I need to connect up a 47 kilo ohm resistor to that pin right there. And then this wire is going to wrap all the way around, and it's going to go to a very specific point on the Nes RGB board, which I will show you guys momentarily. So for now I'm going to just get started by connecting up this wire, and from there we'll figure out the next step. Okay, so the wire with the 47 kilo ohm resistor got soldered over here to this little pad here right next to jumper 5 right here. So that brings expansion audio into the NES RGB board. It gets properly mixed, and then audio out is over here, and that's going to get wired up to the NES I/O board on the other side. Okay, so now that that's done, we can finally start connecting the NES I/O board together with the NES RGB board. So first thing I'm going to do is I'm going to go ahead and just wire together, or bridge together a couple of jumpers. So this one right here, which is J5, that needs to be bridged. That's because we're using an NTSC console. You also need to bridge J3, and that is for power. So if you don't bridge that, then you will get absolutely nothing. So now all of those are done. So next thing we're going to do is we're going to go ahead and start soldering in the pallet, which is right over here. Okay, so now that that's all taken care of, we're going to add 3.3 volts, and helpfully there is a pin right here at the very far end that is circled, and that's what we're going to be using. And man, I cut that wire very close, but thankfully it's just enough to fit in there and not get in the way of anything. So yeah, always be a little bit more careful, and it's better to have a little bit of extra slack than to cut things too short, because replacing this wire would have been super annoying. Anyway, that's all set. So now it's basically the final thing, which is to add in all of the various signals for RGB. I actually got a little bit ahead of myself. So one thing that you need to do with this particular mod board, the NES I/O, is that because we're using Genesis Model 2 SCART cables, those have components built into them, so they don't need 75 ohm resistors on the RGB lines for the Tim Worthington RGB board. So what I'm going to do is the 75 ohms are right here. There's 3 of them. So I'm just going to quickly remove those, and I'm just going to bridge those points so that the signal just passes through straight over to Alright, so that's all set. I always use a little bit of wire to connect these just because I find that it's a little bit more secure than just making a solder bridge. Alright, so now that that's finished, we're going to go ahead and get these final wires connected up. Okay, so I've got all of the wires connected up between the NES I/O and the NES RGB board here. So you can see everything that I've used here. One thing just to note, or a few things to note, when I had set everything up on the NES I/O board, I had actually forgotten to include the ground cable. So I have that in here. I realized it as I was working on it. So I installed a ground cable, and I have that going all the way from that board over to here. And that actually helps connect the chassis ground between the two boards. So it's really important that that's connected. So yeah, you can see that right over here. Here's ground. The other thing too is you have two options for composite video. You have this PPU video, and then you have, I can't tell which one it is. I think it's this white wire over here. I think this is V. It's labeled as V on the board. That's your composite video. So that's the one you want to use in order to enable composite video on the connectors, which are located in the original spots, which is right here. So that's all set. You can see that what I did was I had all of these wires kind of together as they were original. You know, because I got like basically a set of rainbow wire where they're all like basically, you know, attached together. But I found that this was better. So instead of leaving them that way, I separated them out and I passed them through a piece of heat shrink right here. And so that keeps them all nice and bundled and organized, and it's going to get them out of the way of the 72-pin connector, which is right here. All right, so all of those things are done. There's only one other thing to mention here too, which is that I had made a big stupid mistake. And thankfully I realized it, and it was not a big deal for me to fix, but I always want to make sure I let you guys know about this, because I don't want you to make the mistakes that I make. So if I ever make a mistake, I always want to make sure I show it to you. So originally I had installed a socket, a 40-pin socket, and I wanted to do that so that I could easily remove the PPU if I ever wanted to in the future. However, that makes the whole assembly just a little bit too tall, and it doesn't fit in the shell. So I'd completely forgotten about that. I knew that from the past, but like when I was setting this thing up, I totally forgot that adding this socket makes things too tall. So I had to go in with Chip Quick and remove the stupid socket, which I did. And I cleaned everything up, and then I installed the PPU directly onto the NES RGB board. So definitely make sure you do that. Do not install a socket like I did, because it just makes the whole thing a little too tall. All right, so we're on to the very final stretches of this. The next thing we're going to have to do is make a few modifications to the power and reset board. Okay, so what we have to do here is we have to take the reset signal, and instead of sending it to its normal location, we're going to send it to the NES I/O board. So to do that, what we're going to do is we're going to be just quickly desoldering this yellow wire over here. This is the reset going in, and we're going to send that, we're going to basically solder a new wire here and send that to the NES I/O. Okay, so that's desoldered from here, and I'm just going to pull it out of the assembly right here. And we also need to remove it from the socket, and that's not too bad. You just kind of push down on this little part right here. There we go, and you just pull. So you push down here and you pull, and now that wire is totally free. Okay, so this reset line has been soldered, and I'm going to show you where this goes on the NES I/O board. So now the kit also comes with this LED, and it has, you know, four wires, or four leads to connect. And I frankly could not understand how this thing works. I'm used to standard LEDs where you've got an anode and a cathode and it just lights up. This thing, I think it has two colors. I think it has a red and it has a green color. I couldn't get it to work in any configuration. I don't know if it's defective, or I really don't know. So I decided, you know what, like I'm just going to put the original red LED back in and leave that, because that just works, and I don't really need to know when something is changing, because, you know, I'm going to be doing a button combination to change palettes or to reset the system. So having the green LED really doesn't give me anything interesting anyway. So yeah, it was kind of frustrating. I couldn't find good information on exactly how to wire it up, and I honestly think I might just have a bad LED. So I just let that go. I took the original LED and I put it back in. that is entirely optional, that LED. So, you know, the essential thing is this reset inline. You don't need to mess with the LED if you don't want to. All right, so I'm going to just do the final connection. So, oops. Okay, so here's the reset line right over here. And there we go. So with that, hopefully we are all done. And so now let's go ahead and assemble the system and give it a test. Okay, so I've got everything fully assembled, and I just wanted to show you this NES RGB in all of its glory. So right now I have the RGB connected, and it looks absolutely fantastic. I've also tested the composite video and the S video, and those also look great. So what I'd like to do now is just kind of show you some of the features that this system has. So if you hold down the reset button, what you can do is you can cycle through the different palettes that are on the system. So I'll just demonstrate that right now. So you can see I'm toggling between a few different color palettes. So, you know, that's really nice. I mean, this is not something that you do often, but it's nice that you can just do this instead of adding a physical switch onto the back. And yeah, there's a couple of different looks. They all have their own quality that, you know, is great. So yeah, it also can reset the console as well. So let me just go back in really quick. Aside from that, there's also a in-game reset function. So if I select start A and B, and if I just press them quickly, I'll do a soft reset. And then if I hold them down, I'm going to do a hard reset, which you can see makes the system fully reboot. It takes a little longer. So here we go. And so you see it took a little bit longer that time to come back, and that's because it was a full hardware reset. And then the last thing I'm just going to demonstrate here is the expansion audio. So I added in those resistors as the Firebrand X guide suggests. And I don't know if you can hear it. I'll turn up the volume a little bit. But this is a Japanese game. This is Castlemania 3, and this version has 2 channels of extra sound channels, and so it just sounds amazing. So yeah, hopefully that's really clear. So I definitely recommend doing this modification. I mean, the NES RGB is great in and of itself, but then having all of these features at the push of a button instead of having to go to the console and toggle switches is really nice. And most importantly, you don't have to modify the case in any sort of way. So the plastic is totally original. Everything is exactly the way it is. So, you know, like for example, if this is your childhood NES, you can keep it exactly the way it is with no compromises. And you can also fully reverse this and bring it back to a stock condition without too much difficulty either. Alright, so if you guys like this content, then I definitely consider subscribing to the channel. I have videos like this out every Friday. If you're interested in getting some mods done for yourself, check out my website, which is oneuprestorations.com. And thanks so much for watching. I will see you guys next time.